Hi. So, yeah, let's start. So, beginning with the introduction, what is GraphQL essentially? Essentially, GraphQL is a query language for APIs. So, uh, it's used in three different configurations. So, GraphQL is built on top of a database, or like the current way in which we are going to be using is integrate various different systems, legacy microservice or maybe a third-party API. So right now, our GraphQL layer sits on top of our other downstream services like author, content, etc. So what GraphQL internally does is it sort of constructs a graph of all the data points. So each and every service is a sort of node in the connected graph. So For example, the author node would have entries like such as name, author ID, etc. And like same for Pratilipi and series and content. So so coming to how we actually use the protocol, so it's essentially we have two different variations. One is query and one is mutation. So in terms of REST, query would be your gets and mutations would be your post. So the real power of GraphQL is that it allows you a flexible structure um, say in the node author, you would have a huge amount of fields available, such as name, display name, cover image, profile image URL, etc. So instead of the client querying the entire structure, we can be selective about what we are actually going to query. So for example, we pass a ID for the author, like, and I say I just want name and maybe some sort of content. I want the title and the cover image of that content. So something like this would be the response. So the response is a simple JSON structure, and to actually change the data on the server side, you use a mutation. Mutation is something like this. Like you have an input field over here. Input could be any of the these things, fields which are belonging to the particular author. So for example, I just want to change the name over here. I in uh, pass the name as a parameter, and uh, this is the sort of result available to me. So why is a GraphQL better solution than current REST implementations? So the problem with REST implementations is overfetching, underfetching, and it in general, and in a huge code base like ours, it leads to a bottleneck in the developers' time. So overfetching is essentially uh, so if you look at a simple HTTP response for, say, author service or something like that, you uh, say I just want to figure out the meta information of an author, like what's my name, what's my age, that's it. But since like there might be the case that the meta call is not optimized, so because of that you would get a bunch of junk data along with it, uh, like last updated amount of number of followers. So those kind of fields, like the client has no option to filter out those fields. So that's essentially the crux of overfetching. Underfetching is sort of something like this. So say you have to find the you need to figure out the number of followers and posts of a particular user. So you start with a, normal yeah, request for the user ID, then you get the number of via the um, ID you figure out, you try to get the number of posts and the number of followers. So in totality, we have three calls. Like these two calls can be done in parallel. But instead of that, what GraphQL proposes is that uh, you just do one single query, and because of the graph, like sort of each and every field in a graph is interconnected with each other. So because of that, what happens essentially is where did I go? What happens essentially is through the user's node, I can sort of traverse to all the descendant nodes which are connected to it, like posts, title, followers, etc. So, okay. So what's our current solution for the underfetching part is that we have built an OSS service. Like OSS service is our aggregation layer for all the underlying downstream services. So it OSS usually just collects everything and just serves the process request back to the client. But the problem with OSS is that to even make a simple change, you would need to create a new API, in case uh, it's a breaking change, or even if you need to add like simple fields or something like that. So in GraphQL, you can avoid that because, say, if I want to say for the author node, I don't have the age field, so I have to create a new version, like which would give me the age field. But since in the uh, graph everything would be connected, you can sort of reach the age field through GraphQL itself. So one more thing about GraphQL is instead of giving you separate endpoints for each and every GET request, you have a collected endpoint. In our case, it would be slash GraphQL, and you can so you don't need. We solve the problem of having different API endpoints altogether. So by that thing, we in a normal development process, what we actually do is we create the aggregation API on OSS, put the auth checks in auth service, and then we have a pag um, um, entry so that we can map the OSS endpoint back to the client side. So instead of that, what via GraphQL we'll be doing is the auth layer has been moved to GraphQL. GraphQL provides inbuilt capabilities to check um, um, what do I say? If a user is authenticated or not. And since we have just one single endpoint to bombard, we don't need the mapping of PAG itself, and OSS, as I said, like the aggregation is moved to GraphQL. So yeah. So okay. So for the tech stack that which we are using right now is we started the migration something like this. We did a POC on web to see if we could continue using Vuex, the state management system for our web, as it is, by just using GraphQL as a substitution layer for your normal REST calls. Uh, and there was one more POC where we tried the Apollo client. So Apollo is a framework by the Apollo guys themselves. They have provided us both integrations for client and server side. So GraphQL services return in Apollo server, and for web, we saw some distinct advantages for the Apollo client. So I'll explain those. So right now, what we are using on the client side is we are using Vue, and we have managed to completely, not completely, but say 90% of Vuex state management, and shifted most of them to Apollo state management. Hmm. So, so this is the place uh, where GraphQL actually comes into the performance, and everything would be enhanced by the caching layer. So the caching layer is a bit complicated. So we have uh, various different levels. So on the server side, we have something memoized cache. So this is only applicable in a request context. So say in a request context, I call the meta information for a Pratilipi once. So it will be cached, so that for the next time when I'm trying to, uh, within the same request context, I try to access that Pratilipi object, it will serve me from the cache. I don't need to hit the Pratilipi service twice to get the same data. And we have a Redis cache built on top of our GraphQL service, so that most of our requests would be like heavy requests would be uh, only served once. Like for the rest of the time, it would be served via cache. And so then coming to the client side, so we have something called as the normalized cache on the client side. So so one of the perks of different GraphQL is mm, so when I do a mutation on the so this is our normal prod website. So when I try to do something like an update, it wouldn't be directly reflected over here. Like you would need to refresh the site once. But in case of GraphQL, what happens is the mutations have a inbuilt cache system over here. So our update mutation, these would be our cached entries in the table. Like this is our normalized cache for the client side. So what essentially GraphQL is, it's there is sort of an observer over here which would say ki the mutation updates the author info, and because of that there is a sort of chain reaction where the mutation updates the cache is updated, and it's served back to the UI components over here. So that's normalized cache. And fetch policy would be, so case of a normal HTTP call. So as you can see, a request goes over here, and when I try the same thing, it will do one more request. But in case of a fetch policy, because of it, it will try to hit the cache first, and if it's only not present in the cache, then it will go to the network. So right now, yeah, this wasn't present in the cache, so it went to the network layer. And since like the second call for GraphQL, it didn't go because it was already in the cache. Guess so. That's about the caching layer. So what we think is that with the caching layer in place, most of the requests would be served from the GraphQL service itself. Like we won't be bombarding, not bombarding, we won't be hitting our downstream services as much as we used to before. And yeah, and like one more thing is because of Apollo client, like the way how they handle the normalized cache and the fetch policy. So after some period of time, like when the user has browsed the website on a like sufficient amount of time, so the cache system would have been built, like it would have constructed a sort of internal graph, something like this, with the amount of data which is available to it. So say so using that data, it can itself serve most of the requests, like if it's available to it. So at some point of time, like the whole website, like say maybe after 30 maybe 1 hour of surfing, like most of the requests would be served from cache itself, and the user might experience kind of an offline mode sort of thing. So so the roadmap for future is, of course, migrating Android fully. Like right now, since web is much more in our control, we are going with a sort of big bang implementation. Like we are migrating the whole web at once, but it's kind of not feasible for Android. So it's like Kshitij and Roshan are kind of working on that to migrate it piece by piece. And right now for the server side, uh, most of the services which have been migrated to GraphQL server is which are like only specific to web kind of needs, what web needs right now. So like we might need to do these migrations also. So we should be going to production anytime soon. Like we are kind of in the 95% of phase. Like we are right now doing bug fixes and final testing and everything. So this is our team, like who have been working on this. Uh, like Roshan was the one with the original vision. So yeah, I mean that's about it from my side. Any questions?
Hi Akash, Avinash here.
Hi, Avinash.
Yeah, and can you go back to the second slide?
Okay.
Yeah, so as you told that GraphQL is sort of a layer that
Mm-hmm.
sits on the microservice or third party
Mm-hmm.
system. So does it directly interact with the database also, or does it require a service behind it? So
So mhm.
yeah, go ahead.
Okay, as I said, like there are like three configurations. Like you can have GraphQL on directly on top of a database, but in our case, it's not feasible. Like since we already have a lot of micro services in place which handle the sort of business logic on top. So, like in our case, GraphQL is just an aggregation sort of layer for us. Uh,
Okay, so a follow-up question.
mhm,
So how do we actually cut down on whatever, for example, at the home API,
mhm,
we might be needing contents from different section like newly published or recommendations
mhm,
or some category like romance, horror, etc. So
mhm.
how are we able to get that data only that is required? For example, for every section, you should be getting the Pratilipi metadata as well, like summary or so. How does GraphQL ensure that we only get the required data and not uh, every data connected to that resource?
Mhm. So that control is actually instead of the control is handled by the client. Like client can actually request what data it wants. So say I don't want some X field. I won't request the X field. Like
But
if
still, that request goes to that service, right?
yeah, it would go to that service.
Yeah. So at so behind the scenes, it should be getting the entire author metadata response that includes
Oh, yes,
additional.
yes. Got your question. So, yeah. So, ideally, in a ideal scenario, uh, GraphQL would want key each and every field is resolved by one single API, but that's not the case in our in this thing. But the good thing about our implementation is that we have a caching layer, like a Redis layer in place, which would cache the uh, API calls once, so that we are like so for this particular request, it would be hitting maybe say author and content service, but that would be a one-time operation. Like until the amount of time like the data is cached, like maybe for 10 minutes or so, that uh, data would be served from the Redis cache.
Okay, thank you.
Hi Akash.
I,
So, a question regarding the caching part. So, what is the TTL that we had? As you said, is it 10 minutes?
so it depends on situations. So uh,
Uh, for example, like a home content like homepage or a list API, it
mhm,
would have content metadata with it. Few parts of it might be changing frequently, right?
yeah. So we in general we have around 600 seconds of caching on most of the APIs. Like some have 300 milliseconds, sorry, 300 seconds. But besides that, there was one more thing. Like say I'm the author of my Pratilipi. I write something. So when I actually write something, the implementation is in place that will invalidate the cache which the author sees. So, like each and every time when I try to access my content, I'll always see the fresh sort of data.
Okay. So it's handled at each API level.
Yep. So, say maybe something like listen number of reads. Uh, we might cache it for a much more longer period than the Pratilipi's content.
Okay. Ideally, shouldn't it be less time than Pratilipi's content because content doesn't change but number of reads change?
Mm, yeah, I mean, true. So maybe a bad example. So take the example of like your author meta information. That could be cached much more longer than
Yeah.
my chapter content.
Yeah. Cool. Thanks.
Hey Akash, I had a question here.
Yeah.
So, when the cache expires on this, does
Mhm.
it put a lock on filling the cache?
What do you mean by lock?
So, let's say we have about 500 calls coming in every second
Mm,
for an author ka metadata, okay? and you have a 5 second, sorry, 300 seconds ka cache on that call.
Mm-hmm.
The time it expires, let's say it expires at 12:00:00.
Mm-hmm.
Now you have 500 calls at the same time trying to make that call.
Mm-hmm.
What happens here? Does it make 500 calls, or does it make one call putting everything in lock and then resolves with it?
Hmm.
Because they are simultaneous calls.
Yeah, yeah, got your point. I'm not exactly sure on that particular scenario. Uh,
Mhm.
like I could get back to you on that, but I don't think we have any kind of locking mechanism in place. I could check
Mm.
and let you know.
Okay. And does it support like so in couple of cache systems, what happens is, let's say you have a 300 seconds TTL,
Mm-hmm.
and the cache basically gets replenished in 299 milliseconds, so that everything is like a cache hit. Nothing is a cache miss. Is that something GraphQL can provide?
I didn't get your question. Can you?
So, okay. So you have a TTL of 300 seconds for
Mm-hmm.
a URL, for an API. Okay. Let's consider the author metadata API.
Mm-hmm.
When the clock hits 298 milliseconds, let's say when there is only 2 seconds left
Mm-hmm.
for that to expire, can you in the background make a call to that API, get the latest data and keep it with you so that these live calls don't have to wait for it?
Mm-hmm.
Let's say for some reason author metadata takes 5 seconds to resolve. Okay, there is
Mm-hmm.
one heavy API that takes 5 seconds to resolve, and when 300 seconds is over and 500 calls come at the same time, all 500 calls have to wait for 5 seconds for that to resolve, correct?
No, they like they would be executed. Like we would be hitting the downstream services, but yeah.
So
Mm,
yeah, so they have to hit the downstream service, wait for
mhm.
5 seconds or X number of seconds, and then take it back to the user. Is it
Yeah.
at all possible to like preheat the cache?
Mm, I'm. I don't think that's possible. Like we would have to monitor, Redis detail. I'm not sure.
Correct.
Uh,
Is that I'm just asking if that is something that GraphQL provides out of the box.
no, I don't think there is a out
Okay,
of the box solution for that. We might
okay,
have
okay,
to, if we want to do that, build something.
okay. One last question I had. So,
Hmm.
so these are basically coming from the experience that I have been having with like building other services where we have been needing this, and if GraphQL solves this, it would be awesome.
Hmm.
So let's say we are basically trying to replace PAG, Auth, and OSS, a part of all these three systems with GraphQL. So,
Yes.
uh, I mean, you have been implementing cache for a really long time on GraphQL. So, what is your experience? Say, where do you cache? Do you cache at the bottommost layer or the edge layer?
So we cache it on the API call itself, like the, I would say, bottommost layer. The good thing about caching is sort of uh, abstracted out. So like any sort of normal developer who would be working on integrating a new field or new service wouldn't have to really think about the caching layer. Like the caching keys are just the query params of, in our case, and like in some special case we have overridden the cache keys, but like that's a separate thing. So in general, so say you want to integrate maybe Percha, you
Hmm.
just need to focus on writing the REST calls, like integrating the REST calls and sort of the business layer on top of it.
Hmm.
That's it.
Okay. So let's say there's something like the home API, okay, where there is like multiple levels of it. Okay.
Yeah.
So in the home, you have to first call, let's say, a recommendation service, and then
Mhm.
maybe cache it. And
Okay.
then you are calling the actual Pratilipi metadata, then maybe cache it. And
Mhm.
then you are calling the metadata, like from the Pratilipi metadata, you have to again make a call for the read count and the social data and like other things and
Mhm.
cache it. So my question is basically like, do you cache at these levels, or do you directly cache the home page request?
Oh, we cache at those levels, like the
Okay,
individual
okay,
entry
okay.
points, so that maybe some other call for these can sort of reuse them.
Correct, correct. And no caching happens on the like URL layer itself, the home page call layer itself.
No, no.
Okay.